Hey guys, welcome to the 39th C programming tutorial, and in this tutorial we're going to be looking at the hexadecimal number system. And the hexadecimal number system is very important in computer science. It's very useful, but we're going to be getting into that a little bit later. But first, let me just say that the base of the hexadecimal number system is 16, meaning that there are 16 different possible values for each hexadecimal digit. And they are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And this can be a little bit confusing, so let me just go ahead and show you this table right here. So on the left we have all of the hexadecimal digits, and on the right we have all of the values that those hexadecimal digits correspond to. So 0 in hex is 0 in decimal, 1 in hex is 1 in decimal, and so on until we get down to A right here. A in hexadecimal is 10 in decimal, B in hex is 11 in decimal, and so on until we get down to F. F in hex is 15 in decimal. So here are all of the hexadecimal digits, 0 through F. So let's just say that we had some hexadecimal number like C, F7 or something. And let's say that we wanted to convert this hexadecimal number into decimal. So we have this number in base 16 and we want to convert it into some number in base 10 or decimal. So the first thing that we need to do right here is just take this C and convert it into decimal. So C in hex is 12 in decimal. So we can just say 12 times 16, since the base of hex is 16, and then we need to do 2 to the second power, or 16 squared, because C is at the index of 2 inside of our numbers. So 7 F C, so 0, 1, 2. Then we just need to do plus F times 16 to the first, or F is 15 in decimal, so we can just do plus 15 times 16 to the first, again because 16 is the base of hex and because 1 is the index of F inside of our number right here. So 0, 1. And then finally we just need to do plus 7 because 7 in hex is 7 in decimal, 7, 7. And then times 16 to the 0 power because 7 is at the index of 0 inside of our number. So if we were to evaluate this, we should get the number that CF7 corresponds to. So let's just go ahead and do this right here. So 16 squared is 256, so 12 times 256 is 3072, so 3072 plus 15 times 16, since 16 to the first is just 16, so 15 times 16 is 240, so plus 240. Then we just need to do 7 times 1 because any number to the 0 power is 1, so 7 times 1 is just 7. So if we were to just go ahead right here and add these numbers up, we should get what CF7 is in decimal. So let's just go ahead and do that. So 240 plus 3072 plus 7 is 3319. So 3319. So CF7 in hex is equivalent to 3319 in decimal, or base 10. So let's just go ahead right here and check ourselves using the calculator, which we can actually do. We can convert between hex, decimal, octal, and binary all in our calculator. All we need to do right here is just on our calculator change the view to programmer, and then on the side right here you see that we have all of the number systems. We have hex, decimal, octal, and binary. So let's just say that we wanted to convert CF7 in hex into decimal. So we just change this to hex right here, so just go ahead and click hex, then type in CF7, so CF7, and then if we just wanted to convert this into decimal, all that we need to do is just click this decimal right here, and we see we get 3319. So CF7 in hex is in fact 3319 in decimal. And if we wanted to see what that number was in octal, we just go ahead and click octal right here. And if we wanted to see what this number was in binary, we can just go ahead and hit binary. And it also shows the binary right here. So here are all of the bits for 3319. Alright, so why is hexadecimal so useful? Well, first let's just go ahead and take a look at what the maximum value for a signed car in hexadecimal looks like. So the maximum value for a signed car in decimal is 127. So to convert this into hexadecimal, all that we need to do is just hit this button right here, and we get 7F. So 7F in hexadecimal is the maximum value for a signed car. Alright, now let's just go ahead and take a look at what the maximum value for an unsigned car in hexadecimal is. So the maximum value for an unsigned car in decimal is 255. So to convert that, we just hit hex right here, and we get FF. So the maximum value for an unsigned car in hexadecimal is FF. Alright, now let's just go ahead and take a look at what the maximum value for a signed short is in hexadecimal. So the maximum value for a signed short in decimal is 32,767. So we just paste 32,767. That in hexadecimal is 7FFF. And as you can see right here, there's sort of a pattern going on. Let's just go ahead and convert 65,535 into hexadecimal before we jump to any conclusions. So as you can see, the maximum value for an unsigned short is 65,535. So if we just convert that into hexadecimal, we see that it's FFFF. So as you can see, there actually is a pattern. And the cool thing about hexadecimal is you can represent a single byte in 2 hexadecimal digits, which makes doing computer math extremely easy. So as you can see right here, it's really not that hard to remember the maximum value for an unsigned short in hexadecimal. It's simply 4Fs. Well, we know that we can represent the maximum value for a single byte in 2 hexadecimal values, and as you can see right here, there are 2 bytes. So let's just say that we wanted to represent the maximum value for an unsigned int in hexadecimal. So we just need to do 1 byte, there we go, 2 bytes, 3 bytes, 4 bytes. So 8Fs is the maximum value for an unsigned int in decimal. So this is the